Welcome to the applications for small nuclear reactors, or SMRs, and advanced reactors, or ARs, to promote clean growth summit. I am honored to address this international conference on the applications for small nuclear reactors and advanced reactors to promote clean energy growth. And I want to thank Strategic Communications for their invitation to do so. SMR-AR development will be driven by electricity demand, climate change, and clean energy policies. Also, SMRs will have special applications such as serving smaller communities, lightly populated regions, as well as remote locations. In addition, they will be useful for desalination of seawater and widespread air conditioning in demand with the advance of climate change or global warming. So this is an important subject, well worth our attention. First, let us take a look at climate change. As a result of warming, sometimes caused by volcanic eruptions over thousands of years, the Earth has experienced 5 major periods of extinction of life over the millennia. The most notorious took place some 250 million years ago as a result of global warming of 5 or 6 degrees Celsius above what we later have called the pre-industrial norm. This was caused by the release of greenhouse gas, carbon probably, as a result of thousands of volcanic eruptions over a long period. The effect of some 10,000 years of volcanic eruptions was accelerated by the release of methane gas. All of this took place millions of years ago when there were no cities, no humans, and the oceans were 100 feet higher. Only a small percentage of life survived, perhaps 10%. This percentage of survival was a little higher for land creatures than for marine life because the oceans became so hot. The other 4 major extinction occurrences largely had similar causes. This same phenomenon of the ocean heating up more rapidly than some land areas is occurring today. The rate of carbon being added at the present time is being accomplished 100 times faster than at any time in human history before the beginning of industrialization, and far faster than the events described previously, long ago in our geological history. There is 1/3 more carbon in the atmosphere today than at any time in the last 800,000 years. Half of this carbon has been placed in the atmosphere in the last 3 decades. This is why climate change is speeding up, progressing more rapidly, not less, than predicted by scientists. "400 parts of carbon per million in the atmosphere used to be considered by scientists as the bright red line that must not, under any circumstance, be crossed. It was crossed in 2016 and now stands at 411 parts per million. The Paris Climate Agreement identified +2 degrees Celsius above the pre-industrial norm level as that level when catastrophes will begin to occur. But already more than 25% of the Earth's surface is nearing plus 3 C, 3 Celsius. In 2022, there will be a new report from the United Nations International Climate Scientists Group as to where we are. But the last one, in 2015, asserted that even if all the commitments of the Paris Agreement are carried out, and none have been, that will nevertheless bring the world to 3.2 Celsius degrees of warming. This much is probably already locked in as a result of past activities emitting carbon into the atmosphere and the slowness with which this is translated by natural processes into a warming Earth. At the Paris Agreement level, that is 2 degrees Celsius average world level, the world community could begin to experience all the worst and more deleterious effects of climate change, which include rising seas, which will put many island states and low-lying areas generally underwater. As the oceans become more acidic and fires begin, the Earth's oxygen level will significantly decline due to the killing of the phytoplankton in the ocean, not only the primary food for fish, but one of the 2 principal sources of the world's oxygen, as well as the destruction of the Brazilian rainforest, the other principal source of the world's oxygen. Also, the expansion of deserts due to widespread drought in many areas, resulting in the gradual disappearance of arable land and fresh water sources, which could lead to many wars to protect these assets. Dangerous, destructive floods where there are not droughts, and enormous and widespread wildfires, much of the world coming to look like southeastern Australia today. These are some of the catastrophes that will begin to happen as the world passes plus 2 degrees Celsius and only get worse and worse as the temperature goes higher and higher. The repairs required by the damages created by this level of warming could be so expensive that there would be money for little else. But to go on with warming, the plus 4 Celsius level appears to be the real battle line that we will be facing in the future, where Earth, as we have known it, must make a last stand. To exceed this level of plus 4C would put the world on the course toward extinction of life, or at least civilization destruction, at plus 5, 6, 7, or 8 Celsius. At these levels of heat, humans could not live outdoors. As we proceed through these decades of warming, just one other example of the many problems that must be addressed is worth mentioning because it's been so much in the news. The international estimate that there could be hundreds of millions of climate refugees fleeing parts of the Earth that have become uninhabitable in the next few decades. This is far, far, far beyond the issues at the U.S. southern border or in Europe. Millions at the borders, not even tens of thousands, but millions. That's what we're eventually going to experience unless we stop this warming. The objective has been set in many minds to reduce carbon emissions for energy production by 2050. It is a laudable goal, but probably not sufficient. Many scientists now believe that the world has only about 20 years to eliminate all carbon emissions and do everything it needs to do by 2040 to have a good chance to stop the planet warming short of plus 4C. And it should be kept in mind that at some point global warming becomes irreversible. So time and what can and must be done now is of the essence. Emissions to power electrical grids only comprise about 40% of the problem. Transportation is also around 40%. This means we must have electric cars, trucks, and ships. But then batteries to power these vehicles will have to be powered. They don't just operate on their own. But if 80% can be solved, surely the remaining 20% from industry and agriculture, primarily dairy, can be successfully addressed. The answer is nuclear power, and only nuclear power. Only nuclear power can save civilization and accomplish the defeat of climate change, assisted by hydropower, with renewables perhaps as an adjunct. Nuclear power operates around the clock, takes up a relatively small space compared with renewables. It is reliable and has actually powered cities for generations. We know it can do it. Renewables, that is solar and wind power, can remain a source of intermittent power during the critical 2 or 3 decades that lie ahead. That is when the game will be won or lost, most likely. There is no battery revolution underway at this time that can result in batteries powering all of Abu Dhabi at night. The voice of Michael Schellenberger, a Time magazine hero of the environment and president of Environmental Progress, should be listened to on this and many other related issues. He strongly asserts that renewables can't save the planet. That's a quote. He mentions that a mix of renewables and nuclear power, rather than just nuclear power alone, results in more carbon emissions due to the unreliability of solar and wind. He points out that those who support renewables are suffering from an appeal to nature fallacy, no different from when we buy food because it's labeled natural. Also, only nuclear power, because it is entirely emission-free, can successfully power the necessary negative emissions to reduce the amount of carbon already in the atmosphere essential to stop the continued warming of the planet. We have to do that too. Since the beginning of the Industrial Revolution, humans, through the burning of coal, oil, and gas for energy, have released approximately 545 billion metric tons of carbon into the atmosphere, which converts to 2 trillion metric tons of carbon dioxide. Annual emissions are about 37 billion metric tons of carbon per year. So the world is now approaching over 600 billion metric tons of carbon in the atmosphere, which will likely stay there for a very long time. These phenomena have been well understood for many decades, or over half a century. But little has been done about it. In 1976, a prominent scientist at the Pacific Northwest Nuclear Laboratory stated in a public paper that the human race was burning fossil fuels, coal, oil, and gas at too rapid a rate, and the effects on weather patterns and sea levels would be catastrophic. By the early 1980s, all of this was widely understood, and serious efforts were undertaken. By the end of the 1980s, there was support for remedial measures by the U.S. President, a consensus within the U.S. government, full support in the Congress, business sector acceptance, public agreement, and a worldwide common view that the use of carbon had to be controlled in some way. Cap and trade laws were what governments had in mind at this time. If the U.S. and other countries had moved forward then, climate change would never have happened. But the U.S. at the last minute backed away, and without the United States, the international consensus fell apart. The nuclear industry had deeply and unfairly been discredited by the 3 Mile Island incident, and so coal production and its use for power spiked. The end result was that climate change was not stopped. Indeed, the situation became much worse. In the ensuing 3 decades, there was emitted into the atmosphere an amount of carbon equivalent to all that had been emitted in the previous nearly 200 years. So here we are today, nearing the edge of the cliff. Over the millennia, world temperature and weather patterns have varied considerably. Witness the 5 extinctions which took place in the distant geological past. But for the period of 8,000 to 10,000 years prior to the commencement of industrialization in 1800, scientists believe the global mean temperature has not varied by more than 1.1 degrees Celsius. And any slight changes were very slow. But now the situation is different. The planet has warmed a little more than the standard over these recent millennia. Some readings as high as 1.3 Celsius or even 1.5 Celsius have been recorded. But the changes now are happening fast. They are not due to exploding volcanoes, but rather by humanity and fossil fuel use, taking place in decades rather than millennia. But we can defeat climate change with nuclear power. Countries have done it. Swedish energy production is virtually carbon emitting free. It is composed of 50% nuclear and 50% hydro. France is nearly as good, about 72% nuclear and nearly 20% hydro. There are no alternatives. Every time a nuclear power plant is shut down and not replaced by another nuclear plant, emissions dramatically increase. Nuclear plants have been replaced by natural gas plants in the United States recently, creating significant setbacks in the struggle against climate change. Environmentalists should not like this substitution. Emissions for that particular site that is subject to the substitution of gas-powered energy versus nuclear power energy increase from 0 to half of the emissions of a coal plant. But environmentalists have nothing to offer but wishful thinking. Since 2000, wind and solar have been heavily subsidized, but with very little to show for it in terms of net carbon-free power. It is important to remember climate change is not a subject to engage with purely ideological concepts. Reality has to be looked at objectively. We don't want to find out in 2050 that we made a mistake in betting on the wrong technologies. Nuclear power, like it or not, and I recognize some don't like it for both understandable and not understandable reasons, can save us. A heavy commitment to nuclear power will in fact save us. Nothing else will. The world needs to use nuclear power to defeat climate change. Nuclear power is not an option for the future. It is an absolute necessity for the survival of civilization. However, given the short time available, nuclear power deployment has to be done with the technology we now have or will have soon. Fortunately, SMRs and at least some ARs with effort can be available in time. Nuclear power is carbon emitting free, reliable and efficient, as I've said. Very large numbers of deployed nuclear reactors as fast as possible we must build to power cities, countryside, electrical vehicles, air conditioning, and desalination of water. Big reactors made to power large cities are very expensive. Smaller population areas and remote areas need something cheaper. SMRs can meet these requirements. SMRs, in addition, can be used for desalination of seawater and thus have an important role in providing the fresh water which will be in shorter supply. Widespread desalination likely will prove to be a necessary response to this situation. SMRs are super safe. They can be built and installed at a high rate and are entirely passive, no pumps. ARs can add much as well, which we will explore during this conference. Since SMRs are a principal focus of this conference, a bit more on the subject is perhaps desirable. By the term SMR, a small type of nuclear reactor is referred to, smaller than conventional reactors, manufactured at a plant and brought to the site for assembly. Modular types of SMRs permit less on-site construction as well as increased efficiency with superior materials security. One of the principal examples of SMRs is indeed that they can be manufactured at a central factory location. They can then be installed on site without much difficulty. These reactors are particularly useful in more remote locations where there is a shortage of trained workers. Shipping safety and efficiency is always a concern, but on-site containment can be more cost-efficient and proliferation risks lowered. SMRs can be more flexible in that they do not have to be connected to a large power grid, but can be attached to other modules to acquire more power if necessary. Electricity needs in more remote locations fluctuate, and the flexibility of SMR operation is a considerable advantage. Large conventional nuclear reactors tend to be more inflexible and less well suited to serve regions distant from large urban areas. SMRs generally have a load following design so that the reactor can easily adjust electricity production to more closely follow demand. Many SMRs are designed for use with new fuel concepts that allow for higher burnup and longer fuel cycles. Longer fuel cycles can strengthen proliferation protections. Such longer cycles help in remote areas as well, where access is more difficult. Importantly, SMRs could be used to power large production facilities or large vessels. For example, as I've said before, for seawater desalination, which will be much in demand in the era of climate change. Over the years, the demand for power for this type of activity could increase significantly all over the world. Ultimately, SMRs may be deployed at many more sites than large power reactors. Thus, SMRs must be inherently safe. This is, of course, true, and indeed is true of all nuclear power reactors, but this imperative is especially strong with SMRs. For example, many might be located in lightly populated or remote locations where a significant lack of trained personnel exists. Thus, many SMRs use what are called passive safety measures. Such features are engineered so that they do not require outside input to operate. Passive safety systems in an SMR require no moving parts to work. Such systems depend only on physical laws and not outside intervention. Many different safety concepts can be involved in these SMR passive systems. Coolants can use natural circulation, convection, so that there are no pumps, no moving parts that could break down. Negative temperature coefficients in the moderators and the fuels keep the fission reactions under control, causing the fission reaction to slow down as the temperature increases. Nuclear proliferation is a concern for SMRs, as of course for any nuclear reactor. The fact that no civilian nuclear power reactor has ever proliferated into weapons anywhere in the history of the nuclear age is something of which the nuclear industry should be justly proud. Nevertheless, sound plans and constant vigilance, hallmarks of the industry, are required. This is no less the case for SMRs. In fact, this requirement is more compelling for SMRs as they are likely to be sited in far more places than large power reactors. Some AR SMR designs, for example, are such that the individual reactors have lifetime cores, so they do not need refueling. This strengthens proliferation safeguards because it means that no on-site nuclear fuel handling is required. Also, the modular construction of SMRs is another important feature, because the reactor core is, as a rule, constructed completely inside a central manufacturing facility. Fewer people have access to the fuel before and after initiation. Many countries have shown interest in SMRs. In addition to the United States, which is quite actively pursuing this option, Canada, China, and the United Kingdom are seriously interested and have active programs. All reactor systems must be built well. But with that understanding, if the world community begins building these many nuclear power plants soon, rapidly, and well, promptly deploys them, and operates them safely and efficiently, the world community can and will defeat climate change. The result will be an Earth that is not badly damaged, or if it is, it will be sufficiently vibrant to be repairable. If we do not do this and continue our subservience to fossil fuels, the result will either be an Earth burnt out and broken beyond repair, or one which is not even livable by humans. This must not happen. Thank you.